Hey zCienCe, Morgan here. Why don't I kill someone? Well, apart from the fact that it's morally wrong, I could get caught. But could I get caught? In 1985, two teenage girls were murdered. The killer, Colin Pitchfork, made a mistake. He didn't realize that he was his own worst enemy. You see, everyone is unique, and it's all because of our DNA. Although the vast majority of your DNA is identical to that of every other human to ever live, there are tiny differences between your DNA and my DNA. A British geneticist named Alex Jeffries used this knowledge, combined with Pitchfork's DNA, to close the case. But it wasn't as simple as looking at Pitchfork's blood and declaring him innocent or guilty. There were many scientific discoveries that made this possible.
In the late 1970s, Jeffries was working on a project concerning genes, and a thought occurred to him. If genes can be detected in DNA, can inherited differences among people be detected in their genes? He had just discovered the concept that he later coined DNA fingerprinting. Jeffries found that in genetic sequences, there were portions of DNA that appeared stuttered. These were short tandem repeats, or STRs for short. The number of stutters in each person's DNA is different, and that is how he was able to identify people. The only problem is that he still needed a way to read this information to see how long these STRs were.
Jeffries discovered that he could cut these STRs out of DNA sequences using certain enzymes called restriction enzymes. This allowed the DNA fragments to be examined separately from the rest of the DNA sequence. Soon, he made use of this discovery using a new technique called gel electrophoresis. The idea was that he could sort the DNA based on length and charge by exploiting the fact that it takes longer to move something big through a gel than something small. In gel electrophoresis, Jeffries took the fragments of DNA that he cut away using restriction enzymes, placed them on a sheet of gel, and passed an electric current through it. Because the DNA fragments had different STR lengths, they moved through the gel at different rates of speed. The smaller ones moved quickly, and the larger ones took their time weaving their way through the molecular structure of the gel. After a set period of time, the current was stopped and the results were analyzed. At this point, all of the DNA fragments were sorted by length. The smaller, lighter fragments moved to the top of their lane, and the larger, heavier fragments were closer to the bottom, all forming different patterns. This was their DNA fingerprint.
Now all that was left was to match the DNA fingerprints of the suspects to the DNA fingerprints of the killer. To do so, Jeffries took a known sample of the killer and the samples of the suspects and ran them through gel electrophoresis. The suspects with the same banding pattern as the killer sample would be identified as the killer. Through this process, Jeffries was able to identify Colin Pitchfork as the murderer. He did so by isolating the DNA from each of the suspects, using restriction enzymes to collect DNA fragments, putting the fragments through gel electrophoresis, and then observing that Pitchfork's sample had a near identical banding pattern to that of the murderer's sample. DNA fingerprinting has revolutionized the way we deal with crime. Its accuracy has prevented people from being falsely imprisoned and has helped identify people who have caused harm to society. We have Alex Jeffries to thank for this game-changing method of identification.